science educator and amateur astronomer and very famous blogger who loves traveling and writing about the experiences and committed to promotion on practice of science and scientific temper, who will deliver a talk on smart telescopes and astrophotography today. We have with us Dr. S.N. Prasad, who is former professor of physics and principal of Regional Institute of Education, NCERT, Mysore. So I welcome sir in NASNI for this today's wonderful talk from you. And we are in NASNI, sir. NASNI is a National Astronomy Network of IAPT and is a dedicated platform under the Indian Association of Physics Teachers designed to foster, create interest and engagement in astronomy and sky watching activities among the students, educators, as well as general public. And it is also to bridge the gap between new sky gazers and experts by providing structured learning and also mentorship and observational guidance in astronomy and astrophysics. It aims to nurture curiosity, promote scientific temper, and also to connect enthusiasts with leading astronomers, astrophysicists, and experienced sky watchers. And this evening, we all welcome Dr. Prasad for his talk. Before we start the talk, I will request Dr. Govind Lakhotia to kindly introduce our speaker to our audience and then kindly invite Dr. S.N. Prasad for his talk.
So you
Dr.
have
Govind.
already introduced me.
No, sir. Dr.
Well,
Govinda will introduce, sir.
Okay.
Yeah.
well, good evening, everyone. It's my privilege to introduce today's speaker, eminently distinguished personality in physics and education, Dr. S.N. Prasad, who is a former principal and professor of physics at the Regional Institute of Education, NCERT, Mysore, where he served from 1964 to 1999. Now, 87 years old, he brings us over 4 decades of rich experience as a teacher, teacher educator, and educational consultant. Dr. Prasad received his master's degree in nuclear physics from Central College, Bengaluru, under Mysore University way back in 1960, and went on to earn his PhD from Raman Research Institute, Bengaluru in 1981, under the guidance of Professor S. Chandrasekhar for his work on the vibrational spectra of liquid crystals. He received advanced training in science education at the Ohio State University, USA during 1966-67 and later in computer education and software development in UK in 1985 as a part of Government of India's CLASS project, subsequently establishing a computer applications lab at RIE Mysore and developed several educational software packages. Over his long academic career, Dr. Prasad has taught undergraduate, postgraduate courses in physics and allied areas and has also served as a consultant to the World Bank of School Education in several Indian states. He has been closely associated with national bodies such as NCT, NAC as an evaluator, visiting around 250 plus institutions across the country. Equally remarkable is his contribution to science popularization, especially in observational astronomy. He hosts an observational astronomy museum at his home with more than a dozen of telescopes and has chased and observed multiple total and annual solar eclipses around the world, and has traveled widely, visiting about 40 countries and all seven wonders of the world. A prolific science communicator, Dr. Prasad writes extensively on astronomy, astrophysics, physics, science education, travel, and more through lectures, demonstrations, and his blogs. His passion for travel and photography has resulted in numerous photo essays, deeply committed to the practice and promotion of scientific temper, humanism, and the spirit of inquiry and reform. With a great honor, I welcome Dr. Prasad to this platform of NASNI and requesting him to kindly enlighten the gathering for today's interesting topic of astrophotography and telescopes. Sir.
Thank you very much. I'm overwhelmed. I hope I can do justice to your expectations. This smart telescopy is something very recent for me, and I thought I should share my excitement with others. So, with this in view, let me begin my PowerPoint presentation and take you along a journey of discovery of the latest development, perhaps uh, in observational astronomy for both amateurs and professionals, and that is smart telescopes. Okay. Here is a picture, something that you can recognize, and the title is Smart Telescopes and Astrophotography with these telescopes. And I have already been introduced, and I would like to draw your attention to the bottom line and more about it here. I have recently written a blog article on this topic, and you can access that here. And if you wish, you may actually copy this and scan this and look up the article. I'll stay here for a few seconds. I hope this time is enough for you to just scan it and maybe look at the article later. Uh, for me, astronomy started with this man because he was the one who looked at the night sky through his telescopes and opened up an entirely new world of observational astronomy. And that we are still carrying on. And today, you have a plethora of telescopes for both professionals and amateurs. All these are for amateurs. And these are what I would like to call conventional telescopes, because these are rapidly being outdated. And as you know, there are several types of these. The older one is the refractor type. And here is a representative sample of a refractor telescope, which you can carry it around in a bag. And it does a pretty good job. And you can actually see that behind me over here. This side. Incidentally, I have more than a dozen with me, and I think you can see 3 or 4 of them right behind me. Okay, here is another which I use very frequently, another refractor telescope. And better known are the reflector telescopes, bigger, cheaper, and better. And here is a representative reflector telescope right behind me, over there. I think you see that. And despite its small size, it's a pretty good instrument, believe me. And here is something much better, bigger, superior, a Newtonian reflector telescope. These are all part of my collection. And a combination of the two, the refractor and the reflector, gives you the catadiatropic telescopes, more modern, more recent, smaller, even less expensive. And these employ what I call folded optics. You can see that in the diagram behind, how the light path goes through a triple reflection, and as a result, the entire instrument becomes a compact one and portable and easy to use. Here is one such catadiatropic telescope with me right over there. And here is another, it's a go-to type of telescope. Perhaps this is the one which directly leads you onto the modern smart telescope. Now, these telescopes need to be mounted on tripods or whatever mounts. And there are basically three types of mounts. Here you are seeing the more common alto-azimuth mount here. You can rotate it in the azimuthal plane, and then in the altitudinal plane. You can do that. And the older variety of mounts are the more useful equatorial mounts that you see here. If photography is your main interest, then you certainly need a equatorial mount for whatever telescope you are using. The alto-azimuth one is good for viewing, but not so much for photography. And here is a cheaper, a practical version of a mount. Actually, you see it over there. And it is something you can fabricate yourself with the help of a carpenter, actually. And a mount which consists of something that you can rotate in the azimuthal plane and which carries the tube, telescopic tube, small or big, doesn't matter, when it can rotate in the altitudinal plane. So this is a very inexpensive, perfectly fine, but not for photography. This is good for viewing. Okay. These telescopes all suffer from a variety of limitations. They're all manual. You have to operate them manually. And it's not easy for everybody, believe me. I know a lot of people who find it difficult to learn and take a lot of time and often get discouraged and give it up on the way because of the manual nature of the operation. And in order to use it, you should be able to read star charts. In the olden days, these used to be printed, and you had to look up the printed matter. Today, it is much easier. You can open up a chart on your smartphone, look it up, and then find your way about, and a lot easier. And you look at your image through an eyepiece, and getting the image to be visible to the eyepiece, believe me, is not easy. Not everybody. Of course, there are a lot of people who quickly master this, but a lot more of these people find it very hard to do that, in my experience. And all this means you need not only a good deal of skill to use these conventional telescopes, but you need a lot more of patience as well, a combination of both. And this gets people discouraged easily. And the fraction of people who are successful observational amateur astronomers is a very small percentage of those who actually start trying it out. Okay, now there is a transition that I recognize from the conventional telescope to the small telescope. That came about through some breakthrough technologies, especially precision electronic motor control, digital image processing, smartphone interfacing, and all these resulted in a sort of hybrid telescope, something in between the conventional one and the smart one, which we know familiarly as go-to telescopes. You're supposed to be able to make them go to wherever you want them to. It's easier said than done. Those of you who have experience of using these go-to telescopes. Okay, now this brings me to the subject of today's presentation, and that is small telescopes. Okay, here is a sample of that. You can see behind me over here. I'll come to that later. This is one of the earliest models, perhaps the earliest. It was barely 5 years ago that this was unveiled. Somewhere in Las Vegas in the United States. And these developers demonstrated that not only you could use it as a small telescope, but also get very good pictures of these sky objects, which were almost totally invisible even to a telescope from a place like Las Vegas, a light polluted place like that. So they demonstrated that you could use it in such a place. And here is a more recent version of a small telescope, which was perhaps the cheapest of them all. And I bought one, and I'll show you here. This is it. I and my associates have used this, not very much, I'm afraid, but because it's not very easy to use. It is smart, all right, but definitely not easy to use. So we are not really using it very much. It is more of a museum piece right now than a practical device. Anyway, another that's called Hestia. A more recent one, which got introduced to us in Mysore by one of my friends from USA. Okay, this one. It was called Vianus vespera, a more expensive variety, a more versatile variety, and a more recent version is what is called the dwarf. It's an acronym. I don't remember what that is. Is a dwarf, all right, even otherwise. Here is a representative of a very versatile small telescope. It is called the Celestron Origin. It really marks the beginning of very sophisticated small telescopes, which can even compete with the professional variety. And at the other extreme, I recently found that something that you can put in your coat pocket, this is called the Dwarf Mini. This has come out. So it has become unbelievably portable, this whole idea of smart telescopy. Okay. And what are the advantages? These small telescopes have their own brain embedded in them. And of course, I don't have to say that they use a good amount of artificial intelligence. I'll come to it a little, I'll come to it soon. Any smart telescope of today can find itself automatically, can locate itself automatically, know where it is. In every respect, it can happen. And these are controlled with the smart telephones that we use every day, which we carry it with us practically all the time. So you can control your telescope with the smartphone app. And you don't look at the image through an eyepiece. That is not generally not feasible in a smart telescope. Instead, you look at the image on a smart phone screen, and that image builds up in real time. You barely start seeing an image, and as time passes, you see that the definition of the image, the quality image improves over a period of time, and then you can really stop where you want to go until you are really satisfied with the quality of the image that you are looking at. Now, all this is done through a technique called stacking. Now, stacking involves taking pictures at regular intervals, say at 10-second intervals, put these images one over the other, as many as you desire. At the end of each operation, what happens is that the signal to noise ratio improves. You gain signal all the time, but you are losing signal at a faster rate. In other words, the signal to noise ratio improves, the quality of the image improves, And at the end of a number of such operations, you end up with a picture with a great deal more clarity than you started with. And if you wait sufficiently long, you end up with an image which you would not be able to see, not be able to see at all through ordinary telescopes, may not even be able to photograph through ordinary telescopes. So that is it. But this is all done very painlessly. You don't require very special skills. Okay. Now, what is the special advantage? The special advantage of a smart telescope. Now, here I'm saying it in one line. It works well even in light polluted environments. Most of us in urban localities have struggled to make sense out of astronomy because of the amount of light that pollutes our environment. And although there is a great deal of enthusiasm in urban localities, practicing observational astronomy has become a disappearing art. And that is changing thanks to the smart telescope. Okay. Now here is a perfectly clear sky. And here is an urban sky, a sample of an urban sky here. Now this is what is called the bottle scale. This is bottle 1 sky, something you can expect to see in a rural place. Now this is a bottle 8 or 9 sky which we end up with in urban localities. Mysore, where I am, is about bottle 8 sky, typically. Now my point is that these smart telescopes work well even in bottle 8 and 9 skies. That is something almost amazing. Okay. Now here I am introducing you today to one of the smart telescopes which I acquired recently, about 2 or 3 months back. And it comes in a portable case. Let me show you that case. I suppose you are able to see that, right?
Yes, sir.
Yeah,
Yes, sir.
I suppose you are able to see
Yes,
this
sir.
case. It's extremely portable, just about 2.5 kg.
Yes,
And you can carry it wherever you want. And here
yes,
is
sir.
a picture of the entire system, including the tripod. And you use it with a smartphone app. And here is the assembled one, and I'll be showing it now. I hope you can see the whole of that. Can you? Can anybody confirm that you are able to see the whole of it?
Yes, sir.
Yes, sir.
You are. Okay. This is
Yes, sir.
completely assembled. And this comes with its own tripod and the main unit, and the two can be put together in a matter of seconds. And here is the optics. This telescope that I have with me, called C-Star S50, costs us just about $500. In Indian currency, it is less than 45,000 rupees. Although if you want to buy it in India, you will have to cough up about 60,000 rupees. That's what I did. And it employs a very sophisticated optics, believe me, for its size, which is only 50 mm diameter, and a focal length which is only 250 mm diameter. Its optics is really, I should say, quite amazing. It employs a triplet apochromatic refractor design, combining both spherical correction for spherical aberration as well as chromatic aberration in a set of 3 lenses, beautifully designed. Okay. And here is our app. It's a highly intuitive app, which I'll show you now. Let me see. Okay, let me open that. It's called the C Store. It is opening up. And can you see the app here? I think you should be able to see this in my next
Yes, sir.
slide.
Visible.
Yes.
Yes, sir.
Can you see that app here?
Yes, sir.
So this is it. You will have to connect it. Of course, I can go ahead and do it because I am working indoors. The instrument doesn't know what to do, so it gets lost. So I'm not going to try to do that today. Maybe some other time we can do that. Now, here are some specifications of this.
Sir, you can do a.
Oh.
I think you can show demonstration mode.
Yes, I can do that. Yeah. Do we have? Shall we? I'm looking at the clock as well. Shall we do it during our question and answer session? Can we?
Yes, sir. Yes, sir.
Yeah.
We can do that.
Now, I would like to bring to your attention that its picture resolution is not very good. Only 2 megapixel. But there are lots of other things which are good. And it's highly portable, just about 2.5 kg. And Wi-Fi connectivity is very good. Everything else I have found is excellent. Okay. Its drive is ultrazimuth, but that is not very good for quality deep sky astrophotography. So you can do that with an attachment, this attachment, which converts it into an equatorial mount. And I'll show that here. In these 2 pictures, is a fully assembled smart telescope with all accessories and riding on an equatorial mount here, which converts the whole device into an equatorial one. And that gives its tooth for astrophotography. And here are 2 pictures as we actually use them. And here I'm showing you something I could have shown you a little bit earlier. You can see that here is a video clip of that in a sun-seeking mode. It took less than half a minute to locate and lock onto the sun. And you can see there's a cover for that, filter, solar filter for that. Now, if you see that it has located the sun, locked onto that, and thereafter it can follow the sun. And you can take the pictures. I'll show those pictures a little later. And Now, I'll be showing you a number of deep sky objects. These small, very good for deep sky photography, not so good for other types of photography. Okay. Now, practically all the pictures that I am going to show now, one after the other in rapid succession, they were all taken by my associate, Mr. Krishnamurti, mostly from his home, where the light pollution was only slightly better than at my home, only slightly better. Still, it was a bottle 8 sky, I would say. Now, here are a series of pictures I am showing. Initially, we couldn't believe our eyes. Were these the pictures that we were seeing on our smartphones? Yes, they were. Here is something that you can see almost with a naked eye. The Orion Nebula, the great Orion Nebula that you can see here. So this is the picture of that. And here is a picture of a real galaxy in the constellation Triangulum. This is the map of the surrounding skies. And here is where M33 is located. Now, here is what is called the Flame Nebula. I am yet to look at it. I believe it is in Orion. I have not spotted it yet. And this is one of the most amazing pieces of the night sky that you can see. Even with the naked eye, it is possible. And that is the Andromeda Galaxy. Here is the picture we were able to take and look at the satellite galaxy as well. And this is where the Andromeda Galaxy is located. Through binoculars, you can really make it out. With the eyes, it's not so easy. And here is the very famous Horsehead Nebula in Orion. This is, if you look at it carefully, our picture, this is the Horsehead Nebula. Looks much like a horsehead, doesn't it? This is where it is to be found, somewhere here it is to be found, in the constellation Orion. Now, here is the famous M1, Messier object number 1, the Crab Nebula in Taurus. I couldn't believe it that this was our picture. That's how good it is. And this is where it is located. Believe me, it's almost impossible to see it with ordinary telescopes. And here is another galaxy, called the Pinwheel Galaxy. And this is in Ursa Major. This is the location of the Pinwheel Galaxy. And here is another galaxy, Canis Venatici, M51 galaxy. And this is also in Ursa Major. And I have not located it, somewhere here. It should be somewhere here. And here is an amazing picture. Don't you think so? This is the Whale Nebula in Cygnus. And it is, in fact, there are 2 parts of the Whale Nebula. I'm not sure which part this is. Krishnamurti will have to tell me later.
West.
Yeah. And the exposure time is only 15 minutes for this one. Okay. And here is one of my favorite objects in the night sky. It's a double cluster in the constellation Perseus. It is somewhere here. And it's a great binocular object as well. And this is the double cluster. And here you see a globular cluster. Typically, a globular cluster consists of over 1 million stars. This is the very famous Pegasus globular cluster called M15. And this is where it is. Where is it? Well, I have not located it. Have I? No. Oh, no, here. Somewhere here it is. Okay. Now, this is the southern sky. We are able to see it pretty well nowadays in the morning, even from Mysore. This is a very famous Carina Nebula, one of many that you see in this neighborhood, which is near the galactic center, or Milky Way center. Now here you see the Milky Way, and this is where the Carina Nebula is. Here is the Southern Cross. You see it very well in the mornings here. And now I must emphasize that these small telescopes are not very good for solar system objects. Nevertheless, we have taken some good pictures here of the sun, and here a number of dark spots which are enlarged here. And this is, I don't have to say what this is. Every child can recognize this. And this is an enlarged version of that. And we were very lucky to be able to get this on one particular evening. That was on the 3rd of November, Comet Lemon. We were not able to see it later or even earlier. And you can also take pictures of terrestrial objects. Here is a picture of the famous Lalit Mahal Palace Hotel in Mysore, taken from Mr. Krishnamurthy's home 20 kilometers away. Look at the definition of that. And here is the picture of the temple on top of the Chamundi hill, also about 20 kilometers away. And here is a picture of something much closer by. And I don't have to say what this is. This is about 300 meters away. Now, I'll end my talk. I'm on target, actually, for a 7:45 closure to my slideshow. I don't have to tell you what this is.
Yes.
Yeah. This is the Hubble Space Telescope, which has been scouring the night sky. Scouring the sky, I should say. It doesn't know what is night, what is day. For the last 34 years, practically every great advancement in modern astronomy, we owe it to the Hubble telescope. Our knowledge of the celestial wonders has multiplied, gone up manifold through the Hubble Space Telescopes. Just for comparison, here are a few pictures. Compare it with what I showed you a bit earlier, our pictures. Now, I'll have to go back. This one. This is the M15 globular cluster. It has about 10 million stars in it. Here is the great Andromeda galaxy. And here is the M42, the very first picture I showed you, the Orion Nebula. And here is something I did not show you. And that is the famous Ring Nebula in the constellation Lyra. And right at the center of the ring nebula, there is a star which exploded long back. And now let me end my show of the uh, uh, Hubble Space Telescope pictures with what I consider to be the best of them all. The picture of the Crab Nebula, right at the center of this nebula is a star which exploded in 1054 AD, a supernova. And these are the remnants that you see of the supernova explosion that happened in 1054 AD. Now, with these pictures and my comments, my explanations, I'm right on time. 7:45 is when I wanted to stop, and I'm almost doing that. And I would like to offer you another opportunity to look at my article, blog article, which you can get here if you scan it. If you did not scan it earlier, here is an opportunity for you to do that, especially for those who did not join me right at the beginning. Now, with these observations, I will open up the discussion. I'll hand you back to our host. And maybe we can all talk. Not all, of course, not all at the same time. Take turns to talk. And if there are questions which are direct, I think I'll have to look at if any questions are posted. Let me get this. Now, how do I do that? Can any, if you...
We don't have any question in chat box, sir.
Oh, your chat box.
But
Maybe...
we will
yeah.
try
Yeah,
to
maybe we don't have
invite.
any in the chat. Yeah.
Yeah.
Okay.
So thank you.
Yeah.
Thank you so much, Dr. S.
I
Prasad.
hope it was valuable.
Yeah.
Thank you. Right.
Thank you. Thank you very much, sir. Dr. S. N. Prasad, sir.
There seem to be a few questions.
Yeah. Question is, what is nebula?
What is a nebula?
Yeah.
Yeah. The typical beginner's question, what is a nebula? Nebula is the interstellar material, the dense gaseous material from which stars are ultimately made out. Stars are born from the material of the nebula. So these are the cooking pots for the stars. So practically all the nebula eventually will develop into stellar systems. So it's happening all the time. I hope that explains it. This
Yes,
is
another question is from...
gaseous material, self-luminous, most of them. Of course, there are also dark nebulae which you can see through reflected light. Yes.
Yes, Narayan, you ask your question.
Yeah.
Good evening, Prasad sir. It was a very good presentation. And after every image, sir, on the bottom right, I could see the image time that was captured for. So does it mean if we take it for longer period of time, there is more clarity to the image?
Absolutely. Absolutely. But the gain, how much you will be gaining, I think you will have to try out and see, try and see.
Oh,
I think
okay,
it
sir.
requires a bit of trial and error initially. We need to gain experience, gain a great deal of experience.
Yes,
We
sir.
have been doing it for just about 2 months only. And
Okay.
yes, longer exposures, definitely in principle, give better pictures. How much better you'll have to try out and see. There
Okay.
are deep sky objects which
Mm.
matter even minutes. But there
Yes.
are others which they definitely require several hours of exposure, maybe
Oh,
a whole session in the night or early morning. And you may not be able to do that with the basic setup that you see behind me. You need
yes.
to have your equatorial mount.
Oh,
With that, you can definitely uh, expose for several hours and get much better quality. We have done both.
oh.
Okay.
So
Dr. Prasad,
also one
another
more
question
thing.
is,
Oh,
you have more. Another
Uh,
question from Sumitra is,
oh.
can we see stars through mobile phone and which app is used?
Can you please repeat that?
Yeah, question from Sumitra is,
Oh,
can we see stars through
oh.
mobile phone and which app is used to do that?
No, you can. You see, if you are located in a place where the sky is very clear, maybe bottle one, well, I'm sorry, bottle 1 or 2 type of sky, where visually it is very clear, then most of our good smart phone cameras can capture these stars. Even a quick few seconds of exposure can give you good pictures. So if the question is, can we use our